For section 8.3, we are going to learn about linear regression. And we start off here with an example. It says the data on the table below is graphed in the coordinate plane along with two possible lines of best fit. For each line, find the sum of the squares of the residuals and then use that to figure out which line is a better fit. So the dots are the points from the table plotted, and then they have drawn the green and blue lines as possible lines of best fit. And our job is to figure out which one is the better one. So for step one, we have to find the residuals for each line. So residuals are negative when predicted y is greater than the actual. So they gave us, they put the t-table here, the same points that are in this table here are now here in columns, and we have to first use the equation 1/2 x plus 3. So we're going to plug in the x value of 2 here. So I'm looking at this, and I'm going to plug a 2 here for x. So half of 2 is 1, 1 plus 3 is 4. And then I'm going to move on, and I'm going to plug a 4 in. Half of 4 is 2, and 2 plus 3 is 5. And then 6, half of 6 is 3, 3 plus 3 is 6. 8, half of 8 is 4, 4 plus 3 is 7. And then remember, for residual, we have to take the actual and subtract the predicted. So I have 6 minus 4, which is 2, 3 minus 5, which is negative 2, 7 minus 6 is 1, and 5 minus 7 is negative 2. So that's all for the 1/2 x plus 3 equation. Now we're going to take a look at the 1/2 x plus 2 equation. So again, I'm going to go back over there and find my x values. The first one is a 2, so I'm going to plug in a 2. Half of 2 is 1, 1 plus 2 is 3. And then we got to plug in 4. Half of 4 is 2, 2 plus 2 is 4. And then we're going to plug in 6. Half of 6 is 3. 3 plus 2 is 5. Half of 8 is 4. 4 plus 2 is 6. And then to find the residual, we're going to come all the way back over here to the actual column, so this column here, and we're going to subtract our predicted column here. So actual minus predicted again. So we have 6 minus 3, which is 3. And then 3 minus 4 is negative 1. 7 minus 5 is 2, and 5 minus 6 is negative 1. And then we're going to look here. This is a graph of the residuals of each line. And for step 2, we're going to square the residuals and find their sum. And we know that the smaller sum is the better fit. So squaring them is taking the residuals and taking them to the second power. So I have to do that for this column and this column. Those are my two residuals. Oops. So I have the top one here in blue is 2, and 2 squared is 4. And the next one is negative 2, and negative 2 squared is also 4. And then we have 1, 1 squared is 1, and we have negative 2. Negative 2 squared is 4. So we're going to add those together. That's going to give us 13. Now we have to do that for the other column here. So I'm just going to write these numbers over here. We have 3, and we have negative 1, 2, and negative 1. So 3 squared is 9. Negative 1 squared would be 1. 2 squared is 4. And negative 1 squared is 1. So if I add those together, I get 15. And right here it says the smaller sum is the better fit. So 13 is definitely smaller. So the better fit is in blue, which is the y equals 1/2 x plus 3. Now we have a couple of vocab words here to take a look at. The least square line is the line of fit for which the sum of the squares of the residuals is as small as possible. So that's exactly what we just found. We found the least square line. So we squared the residuals and we found the sum that was the smallest. The line of best fit is the line that comes closest to all of the points in the data set. And then we have linear regression, which is a method for finding the least squares line. So we are going to use the calculator now to find the linear regression. And for those of you in class, we are going to use the graphing calculators. And for those of you outside of class that are virtual right now, we are going to use the Desmos linear regression calculator. And I will put a link, or there will be a link right under the link to the video for this calculator that you need to use. So example 2 says the table shows the latitude and average temperatures for several cities. Use a calculator to estimate the average temperature in Vancouver, Canada at 49.1 degrees north. So the first thing that we're going to do, I'm not going to go down here to the steps because those are all the steps going through the calculators that are actually at school. So we're going to go over here to this calculator, and it's going to have this all set up for you. The only thing I have done so far is changed these numbers over here in the X and Y columns. So I took the numbers here. These are the first ones were the X and the second ones were the Y, and I typed those in that table. And that's all I did. It automatically plotted them over here. Oh, I guess I zoomed out. It was really zoomed in like over here and I couldn't see it. So I just moved my screen so that I could see the points and the line. So it automatically puts them there for you. That's great. It puts the linear regression on there for you. And then if you scroll down over here on the left-hand side, it gives us a lot of information. So the residual squared is 0.892. The correlation coefficient is negative 0.9. And remember, the closer it is to 1, the tighter they are to the line. And you can see that over here. And then we have M is negative 0.69286. That's our slope. And B is 39.1139. And that is our y-intercept. So we can use that, those M and the B, to write our equation for that line. And I'm just jotting them down on a piece of paper so that I can go back and write them in our notes. All right, so if I go back over here, I'm going to write the equation y equals, the M value was negative 0.69286, and then that's x, plus B, and B is 39.1139. So they asked us to use that line to figure out to estimate what the average temperature in Vancouver, Canada would be at 49.1 degrees north. So then all I'm going to do is put 49.1 in here for x. So I'm going to do negative 0.69286 times 49.1 and add 39.1139. And when I do that, y will equal 5.094474. So the average temperature is about 5 degrees Celsius, and that's what it says over here in the chart. So roughly 5 degrees in Vancouver, Canada is the average temperature according to the information that we have.